Hi, welcome back to the channel. Today we are looking at one of the most exciting new boards from Arduino, the Arduino UNO Q. This is actually the board, it's brand new. I just acquired this a few weeks ago. And this is actually not just another microcontroller board. The UNO Q blends a full Linux capable application processor with a real-time microcontroller, all inside the familiar UNO form factor. If you're interested in embedded systems, AI at the edge, robotics, or advanced prototyping, this board actually opens up a whole new workflow. So this video is dedicated just to have a look at this, and maybe at the end we will try out an example. So what makes the UNO Q different? The UNO Q features a Qualcomm Dragonwing QRB2210 application processor. So this processor is designed for edge AI, embedded vision, robotics, and even gateway applications. So it also features an STM32 real-time microcontroller, which is able to run up to 160 MHz for deterministic timing and control stuff. So together these processors let you split the Linux for intelligence and the microcontroller for precision. Arduino introduces an Arduino App Lab, which is a unified environment where we can develop Python apps for the Linux processor and also Arduino sketches for the microcontroller, as well as you can also develop AI models for the on-device inference. All this is in one workflow. You can use either the Arduino IDE program only the microcontroller if you prefer, or even integrate the Arduino CLI with VS Code for more advanced workflows. You can use it as a full Linux single board computer because it runs a Debian based Linux operating system on the Qualcomm processor. This means you can use apt to install software packages like you run Python, Node.js, or even compile C++ applications. And you can also deploy AI models using frameworks like the ONNX runtime or TensorFlow Lite. And you can also host local web dashboards and IoT gateways. So who is this board for? This board is ideal for students learning embedded Linux and microcontroller architectures. It's also for makers working on smart home, robotics, and IoT projects, engineers developing edge AI prototypes or real-time control systems. So if your project needs both intelligence and precision, the UNO Q actually gives you both in one board. So it's very interesting to have this board. Go to the Arduino website, and so this is the website. Probably they have get the Arduino App Lab. So you select that you need Arduino, the version for Windows 10 or 11, and then you download. So once it's downloaded, you find it in your, then you install. So we have yes, the next is next. You install it on Arduino. So this is the space you need. Then it's next. Finish. So it's pretty complete. So we can open it here. So there's no device connected. So we have to connect a device. I'm using USB-C. So I'll connect the board. This is for the first time and see how it reacts. So this is how I connect it. Right. So this is how it So I have this Arduino animation. So once it's connected, then you can see that there's an Arduino UNO Q that has been connected. So the first thing is that you need to, I think it says we need to update the board software. So they highly recommend you update your board using the Arduino Flash tool. So let's get the Flash tool. Okay, so here, so we need to find the Flash tool, easily install Arduino easily flash Linux images into your Arduino Q with the Arduino CLI flasher. So Arduino CLI flasher. So then I will download the Arduino CLI flasher for the Windows. Okay, now here I need to find how to use for the Arduino CLI flasher. So I have downloaded it. So the download is on Windows, unzip the files, and then we find the CLI, and then we will check this. Alright, so it's on my download files, so I'll have to unzip. Okay, so I'll extract it here. So it's here, and then I have this CLI, then I will install it. Okay, I think it's done. And then according to the instructions, the terminal, so I need to find the terminal. I think I can use the command line here, and then I need to run Arduino flasher CLI. Okay, I need to okay, so I need to navigate to the folder. So I need to navigate to the folder. The folder is, this is the folder. I copy this CD, so, and then I can now run the CLI. Okay, so CLI I have to do, but I don't know to flash that. Okay. So I get this, and meaning that it's working, and so we can proceed to flashing the board. So to flash the board, the instructions are here that we have to disconnect the board from the computer. So I will disconnect. So add a female jumper on these two pins. So to prepare the board for updating or flashing, so you need to connect a jumper pin, connecting these two pins here, like this. So then you can flash the board. You can run this command. So you say yes, then I can say yes. So you download this and then we will flash it. Okay, so it says now the board has been successfully flashed. You can now power cycle the board and plug and play. Remember to remove the jumpers that we added. So let's do this. So we unplug the board. So we will unplug the board, remove the jumper. Okay, so having removed the jumper, now we can power cycle the board now. Okay, so it's up again. So then, and it's running, so I can connect. So we need to set the keyboard layout. I need English. I just need to set the English keyboard. I set the board name. I will use the Arduino UNO as my board name. So I will have to connect this to the network. So let me connect, and then I have to find the password. Okay, so I will confirm and then see. Okay, if persist doesn't flash, I'll contact him. Okay. Error checking for updates, board update error. So what's happening? So actually, after I closed the App Lab and started again, now it could find the updates somehow. So I will install the updates. Okay, so it works. Maybe now it's actually working. Probably the problem was I have to restart the IDE. Okay, so after doing this, we need to restart App Lab. So the board update completed successfully. Then now we can start. So I will have to set a password. Okay. So I need to confirm. Okay, it needs at least. Okay, so okay, then confirm. Okay, I need to confirm. So I want to run an example from the examples that we have here. We have a number of them, from air quality on the LED matrix. But let's start with the blink app, the blink LED example. So when you open an example, it has a README file that actually describes how the examples is going to run. So for this one, we have an LED attached to the STM microcontroller, and we have a Python script on the Linux side. So here's the description. How it works basically is that we have what we call a router bridge. So that is the communication that has been provided between Python and Arduino. So at the end of this file, there is also some description to help understand the code. So we have the Python using the time module to toggle the LED after a specified time, in this case 1 second. And this bridge is exposed to the Python side using another bridge provider, which registers this function to be callable from the Python side. So this is a way that has been designed to allow the communication between the two sides of the board. So here we find the files. This is the Python file. We have a global state of the LED state, which we toggle and call the bridge, and providing it with as a function. And then when you have the sketch is what actually runs on the microcontroller. We have here the bridge initialized with this function exposed. So what you do is just run. It will upload this code to the Arduino UNO Q, and then it will provide a console, and we will be able to see that it's working on the board. We have a serial monitor here. We have a Python script. Now the app is starting and it is actually running. So back to the board, I will show you it working. You can see the LED is blinking, so to indicate that there's a communication between the Python script and the sketch on the microcontroller. So that is a simple illustration of the working between these two systems, so the same system. You can go back to many other examples, and in the next video I will do another example that is based on machine learning and AI.